Welcome to our Heron's formula notes. We're going to begin by a brief recap of our special right triangles because they're going to play an important role, not necessarily in this particular unit notes, but in the ones that we're going to do next. So just want to keep those in mind. All right, so you remember that pattern for a 45, 45, 90 right triangle is square root of 2 times the leg equals the hypotenuse. So if the leg is x, the hypotenuse would be x radical 2. All right, my pattern for a 30, 60, 90 right triangle is that the long leg is the square root of 3 times the short leg, and the short leg multiplied by 2 is the hypotenuse. So x radical 3, 2x is my pattern. So when you're solving special right triangle problems, sometimes they're really easy and the answer just jumps out at you. Sometimes they're a little more complicated. On the ones that get a little more complicated, I like to go ahead and write down the pattern and then place my leg that I know where it's supposed to go in the pattern and then follow from there. So, for example, in my 45, 45, 90 triangle, my pattern is x, x, x radical 2. And in this case, the thing that I know is a leg, 3 radical 2, which means the other leg is also 3 radical 2, which means that the thing that I'm looking for is my hypotenuse. So I take x, which is 3 radical 2, and I multiply it by the radical 2 that's in my pattern. And radical 2 times radical 2 is radical 4, and the square root of 4 is 2. So it winds up being 3 times 2, which is 6. That is my answer. All right, same thing works. X, x, x radical 2. This time the piece that I know is the hypotenuse. So 12, which means that these two are equal to each other. So 12 equals x radical 2. To solve for x, I got to divide by radical 2. But we all know we cannot leave a radical in the denominator, so we have to rationalize. And that means that on top we get 12 radical 2, and on the bottom, again, radical 2 times radical 2 is radical 4, square root of 4 is 2, so we get this. Well, these can divide, so 12 divided by 2 is 6, and I keep the radical 2. So this is the answer to my leg. So sometimes it's not quite as simple as just simply multiplying by radical 2 to get your answer. All right, same thing holds true for my 30, 60, 90 pattern. So in this case, it is x, x radical 3, 2x. And when I place what I know into my pattern, this is where it goes, 2 radical 3, which means that my long leg right here, so this is y, and this is going to be the x that I'm looking for in my figure. So the x is pretty easy to find. I take my x and I multiply it by 2, so 2 times 2 is 4, so I get 4 radical 3. And then in this one, I get 2 radical 3 times radical 3. And radical 3 times radical 3 is radical 9. Square root of 9 is 3, so it's 2 times 3, which is 6. So this is 6, and this one is 4 radical 3. All right, you go ahead and do number 4 and come back when you have an answer. Hit pause now. All right, you should have gotten that x equals 2 radical 6 and that y equals 6 radical 2. If you do not know how I got those answers, then you need to ask about that in class. Moving on. All right, we got some more problems to work here. 45, 45, 90. So these two are both going to be the same. And x, x, x radical 2. This time my 17 goes here. So I set these two equal to each other and solve. 17 equals x radical 2. Divide. Rationalize. And I wind up with 17 radical 2 over 2 for both x and y. All right, let's look at number 6 here. So number 6, let's see, is a 30, 60, 90. So x, x radical 3, 2x. Where does the 3 radical 2 go? Well, it goes right here, 3 radical 2, which means that these two are equal to each other. So 3 radical 2 equals x radical 3. To solve for x, we divide by radical 3. Okay, well, this won't work. We're not allowed to have a radical in our denominator, so we have to rationalize. So I'm going to multiply by radical 3 over radical 3. Well, this time I multiply the two radicals together, so I get 3 radical 6 in my numerator. And then down here, I get radical 3 times radical 3 is radical 9, and the square root of 9 is 3. Then these two cancel each other out, which means that m down here is simply square root of 6. And then to get my hypotenuse, which is n, right, so this one was m, this will be n, I simply multiply whatever x is by 2, so I get 2 radical 6 for n. So it gets a little bit harder than simply filling out the pattern, especially if you're not good at radicals. These next two are fairly straightforward, so I'm going to ask you what the answer to these two are in the notes check. All right, let's talk about this fun problem right here. You are going to see problems like number 9 and number 10 again sometime in the near future, if you know what I mean. So it's important that you understand how to work these problems. So we need to figure out what we have going on here. And we have both a 45-45-90 and a 30-60-90 right triangle going on. The piece that we know is we know the hypotenuse of the 30-60-90 triangle. So we got x radical 3, 2x, and that means that the bit that we know is this one, 12 radical 3. Okay, well, the thing that I'm looking for, y, it is the long leg of that triangle, which means that I need to really know what x is in order to figure out what x times radical 3 is. Well, x is half of 2x, so I take this, I divide it by 2, and I get 6 radical 3, and then I'm going to multiply. So I'm going to multiply 6 radical 3 by radical 3. Those two become square root of 9, which is 3, so I get 6 times 3, so it's 18. So y equals 18. This is 18. Well, now it's pretty easy to figure out what x is, because if the leg is 18, then the hypotenuse of my 45-45-90 right triangle is going to be 18 radical 2. So that one was much easier once I had found y. Moving on to 10, we need to find the long leg of this 36-90 right triangle right here. Unfortunately, what we know is the short leg of this one right here. So if this is a short leg 16, then the long leg is going to be 16 radical 3. That long leg of this triangle is now the hypotenuse of the middle triangle. So the hypotenuse of this triangle right here, x radical 3, 2x, is going to be 16 radical 3, which means that the short leg is going to be 8 radical 3, and the long leg, which is the only leg that overlaps this triangle that has the piece we're trying to find, is going to be 8 radical 3 times 3. Sorry, times radical 3, which means that it's 24. So this piece right here is 24. Well, if the hypotenuse of this triangle right here is 24, x radical 3, 2x, then that goes underneath the 2x, 24, which means that x is 12, which means that x radical 3 is 12 radical 3. So the thing that I'm looking for, x, it's the long leg of that triangle, which means that it is 12 radical 3, and my units are feet. And that's my final answer. So you've got to kind of work your way backwards, and you have to basically solve all three triangles in order to find this long leg of the third triangle. Be sure you can do this problem. Let's talk about 11 here. The diagonal of a square is 12 inches. Well, whenever a problem mentions a figure but doesn't draw it, it's a good idea for you to draw it. So there's a square, and the diagonal of that square is 12 inches. So 12 inches. And it wants to know what the area of the square is. Well, area of a square is side squared. So what I really need to know is what my side is. Well, if that's a square, that's a right angle. And if that's a diagonal, it cuts it into a 45-45-90 right triangle, which means that I have x radical 2. And what I know is that x radical 2 is 12, and I really need to know what x is because that is the length of the side of my square. So I set these two equal to each other and solve. Divide by radical 2, rationalize, and I wind up with 12 radical 2 over 2. This guy reduces, so I wind up with 6 radical 2. And then I have to square it to find the area of my square. So I take that 6 radical 2 and I square it, and that basically means I take 6 and I square it, and I take the square root of 2 and I square it. Well, 6 squared is 36. These two cancel each other out. They are opposite operations, so I wind up with just 2, which means that my final answer is 72 inches squared. All right, let's look at problem number 12 here. I'm looking for a bunch of different things here. I'm looking for G, F, and H. And all I know is that the long side of this triangle is 16. And they tell me that this whole angle here is 105. But I know if that's true, and this piece is 30, and that's 90, then this part of it has to be 60, which means that this angle right here has to be 45, so that these two together add up to 105. So I've got a 30, 60, 90 triangle, and I've got a 45, 45, 90 triangle. And what I know about my 30, 60, 90 is I know that the hypotenuse is 16. So in my x radical 3, 2x, I know the 2x, and I know that it's 16, which means that x is 8, and this is 8 radical 3. Okay, so the way that helps me is, first of all, I've found f. F is the long leg of my triangle, so I know that f is 8 radical 3. Okay, but I need to find h and g. Well, the short leg of my triangle is 8, and that goes right there. If that's 8, and this is a 45, 45, 90 right triangle, then g must also be 8. So now I know that g is 8, and that means that my hypotenuse is square root of 2 times that, so my hypotenuse is 8 radical 2. And I've now found all of the missing pieces of my triangle. All right, so that's special rights. That's a little more challenging than what we did in our previous notes on special rights. Be sure that you understand how to use all of those patterns backwards, forwards, inside out. Let's move on to the real point of this note, which is Heron's formula. However, these notes are getting really long, so I'm going to end part 1 of these notes right here, and we're going to tackle Heron's formula in part 2. Please be sure to move on to part 2.